Good evening, everyone. I'm Professor Andrei Zvelindovsky. I'm head of School of Mathematics and Physics at the University of Lincoln in the United Kingdom. And I'm very pleased to welcome Don Kurtz. Hello, Don.
Hello, Andrei.
This is our 14th Astro-Chat with Don about various astronomy and physics things. And I believe most of you already know by heart biography of Don. Just say that Don is extraordinary professor in Northwest University in South Africa, where he is right now. So we connected via this link. And he also visiting professor here in University of Lincoln in United Kingdom. If you want to read more about Don, please click in the link in the description of this video, where will be abstract of this event, as well as link to Don's bio. And during our Astro-Chat, we encourage ask questions which you can type in a live chat under the this YouTube video, and then we'll try to answer as many questions as we can. And now, floor to you, Don.
Okay, thank you very much, Andrei. Good evening to all of you who are in the UK or in this slice of the world. For those of you who are in the United States, good day to you. Elsewhere in the world, it may be good morning or good night. Let me switch over to my presentation. So I will now share this with you. And I need to know from you, Andrei, does that look fine? Right.
Yes, it looks fine.
Okay, right. Tonight I'm going to talk to you about the wonderful little moons of Mars. I've had quite a fascination with these moons since I was very young, and I want to share some of that with you tonight, both about the moons and about the people involved in their discovery. Just for some background, Phobos and Deimos, the two moons of Mars, fear and panic in Greek are their names, are very small, tiny compared to the Earth's moon. You'll see in this graphic that Phobos, and let me get a laser pointer here, Phobos is only 22 kilometers along its long axis, and you can see it's rather potato-shaped. Deimos even smaller, less than 13 kilometers across. And these moons orbit very, very close to the surface of Mars, giving some unique characteristics. The title of the talk, The Hurtling Moons of Barsoom, takes us back to this man, Edgar Rice Burroughs, who started a series of books about Tarzan of the Apes, the first one published in 1912. Those, of course, were very popular pulp fiction. Edgar Rice Burroughs actually was a pencil sharpener salesman for 7 years before he started writing, and one of his goals was to show how bad a book he could write and still get it published. Tarzan ran for decades. It was made into movies and is widely popular around the world. I'm sure all of you know the name of this character. But Edgar Rice Burroughs wrote lots of science fiction. Myself, as a teenager, read his science fiction. And one of his series was a series of 10 books about a Virginian man, John Carter, who gazes up at Mars in the sky and is miraculously transported to Mars, where he finds maidens and monsters and adventures and a life. Now, Mars is beautifully up in the sky. For those of you in the Northern Hemisphere, tonight in Lincoln, if it's clear and you go out, Mars is beautifully high in the sky. Look to your south, southeast right now, but it'll be south by the time the talk's over. And it's shining very bright, just up from the Pleiades in Taurus and not too far from the bright red giant Aldebaran, also in Taurus. So John Carter stared up at Mars and somehow magically was transferred to Mars, and the Martians themselves in these books called Mars Barsoom. Now, I picked that up when I was a student, University of Texas in Austin back in the 1970s, when I read this book, The Cosmic Connection by Carl Sagan. Many of you will remember Carl Sagan from his series Cosmos. That was remade recently by Neil deGrasse Tyson, so it's had a new version that's come out. And this book in 1973 of Carl Sagan's, I read when I was a graduate student in Texas and was captivated by many of the stories. Andrei, you may be interested in case you don't know it. Sagan was born in Brooklyn, New York, but his father was an immigrant from the Ukraine. Ukrainian immigrants have big impact. Now, in chapter 15 of The Cosmic Connection, Sagan says, but the name invented by Burroughs that's haunted me across the years is the name he imagined the Martians gave to Mars, Barsoom. And it was the one phrase of his more than any other that captured my imagination, the Hurtling moons of Barsoom. And that is, of course, where I took the title for tonight's talk. It really comes from Edgar Rice Burroughs, but I got it from The Cosmic Connection and Carl Sagan. Just a little bit further information, Sagan didn't put that in The Cosmic Connection. In the language that Burroughs made up for the Martians, Barsoom meant eighth planet or eighth thing. And what he counted was from the sun. He counted the sun, Mercury, Venus, Earth's moon, Earth, the two moons of Mars, and then Mars, making Mars the eighth thing out in the solar system from the sun. Hence, in their language, Barsoom. Now, taking you back a couple centuries, here's a book that we all know as Gulliver's Travels, but Jonathan Swift actually wrote Travels into Several Remote Nations of the World in 4 parts by Lemuel Gulliver. He was first a surgeon, then a captain of several ships. And if you look at the bottom and you read Roman numerals, you see that this was 1726. 1726 this was published. It was a satire. It had political commentary, but it's remained a delight the world over and is still very current in our cultures. Most of us know that of the Lilliputians, the small people, the Brobdingnagians, the big people. And in the third of Gulliver's adventures, he was shipwrecked by pirates and left on a small rocky island near India. And he was rescued by the people of Laputa. Laputa was a flying island. All right, this isn't physics, folks. This is, in that sense, science fiction. But Laputa was a flying island, and the people there specialized in music, mathematics, and astronomy. But they never did anything practical. And the Laputan astronomers said that Mars has 2 moons with orbits 3 and 5 Mars diameters, periods of 10 and 21.5 hours. The actual Phobos and Deimos have orbits of 1.4 and 3.5 Mars diameters and periods of 7.66 and 30.35 hours. And you have to think this is remarkable. Could Jonathan Swift actually have known that Mars had moons when, as I'm going to tell you, they weren't really discovered until 1877? And the answer is almost certainly not. This is a guess by Swift, and it was a guess that he got from 2 centuries earlier from the great German astronomer physicist Nicholas Copernicus. Copernicus reasoned in one of his books that if the Earth has 1 moon, and Jupiter has 4 moons, the 4 Galilean moons that were known in Copernicus's time, then since Mars lies between the Earth and the moon, it should have 2 moons. And he was thinking in terms of a geometric series where each thing doubles each time. So starting with 1 with the Earth, double it for 2 for Mars, double it for 4 for Jupiter. And although Copernicus didn't say, we might guess he might have thought Saturn had 8 moons, and he didn't know of Uranus and Neptune and the farther planets. Well, Jupiter and Saturn have got vastly more moons than that. This was just a guess. And we think that's where Swift got that remarkable 2 moons of Mars and those orbits that are not too far from the real orbits of Phobos, not discovered for a couple of centuries after him. The real discovery came from an American astronomer named Asaph Hall. Asaph discovered Phobos and Deimos in August of 1877 over a period of 6 days. First, he found Deimos, and then he found Phobos. He was using the U.S. Naval Observatory 26-inch Alvin Clark refractor, which at that time was the largest refracting telescope in the world. Asaph Hall, early in his life, was a carpenter, but eventually got training, became an astronomer. I'll tell you a little bit more about his astronomical background and how he ended up at the Naval Observatory in just a little while. But here is a picture of that Alvin Clark refractor still today. Here's a group touring it and looking at it. Refractors are very, very long telescopes. You can see here the size of the telescope, even though it's only got a 26-inch diameter. Now, Asaph Hall had an interesting experience one night. He was observing at the Naval Observatory, and late at night he heard a tapping at the trap door below him, which was the way to get up to the observing floor of the telescope he was using. He finished his observations, and then he went over and he opened the trap door, and the head that popped up was that of Abraham Lincoln, the President of the United States. The U.S. was in the middle of its Civil War, 1861 to 1865. President Lincoln had been to visit Asaph Hall and seen through his telescope, and he was puzzled by something. And he had walked through the dark, through the streets of Washington at night by himself, no bodyguards, no need of them, even though it was in the midst of the Civil War, and came to ask Asaph Hall why the images were reversed in his telescope. Here is why it was hard for Hall to discover Phobos and Deimos. They're very close to the planet Mars, and Mars is extremely bright and has quite a glare, and it takes a lot of effort actually to see them. In the case of Asaph Hall, he actually pushed Mars off to the edge of the field of view so it was blocked from his sight, so that he could then see the much fainter moons just to either side. And that's how he actually picked them up in August of 1877. Let's have a look at Mars and put it in perspective, and then we'll look at the moons. Here's a beautiful picture of Mars from the orbiters that orbit Mars and take fantastic pictures of it. It's only half the size of the Earth, and you'll see in this picture that Mars is rent asunder across the entire hemisphere here by the great Valles Marineris. This canyon is 5,000 kilometers long. It would stretch across the entire United States if it were in North America. Here in Africa, it would easily stretch from where I am down on the south coast all the way up past Nairobi on the equator. And over here, you can see giant volcanoes, much bigger than any volcanoes here on the Earth. Mars, being so much smaller, has a very thin atmosphere. And I think many of you will know, many people are now trying to plan missions to Mars that will take humans there to land on the surface, hopefully survive, and return home. To put Mars into perspective, there it is to scale next to the Earth. You'll see it's only about half the size of the Earth. That means anybody standing on Mars would have a weight of only about 39% the weight on the Earth. You'd move around a bit more easily on Mars, but nowhere near so easily as you'd move on the moons, as we're going to see in just a little while. So there's Mars and the Earth in comparison in terms of size. Here's the Earth and the Earth's moon in comparison size, but not in comparison to distance. This doesn't give the scale of the distance, just to give you an idea of the size of our moon. Smaller than Mars, but still quite large compared to planet Earth. In terms of the distance between the Earth and the moon, here's the scale. There's the Earth, and there's the moon in scale to size and distance. The moon's on average 384,000 kilometers from the Earth, and it takes 27.32 days to orbit the Earth. It orbits much more slowly than the Earth rotates. And that affects how we see the moon rise and set and move through our skies. And I'll compare that for Phobos and Deimos, who are quite different, for astronauts someday when they land on the surface of Mars to look up and watch these moons in the sky. There's a beautiful picture from one of the missions of the surface of Phobos itself. Remember, its long axis is 22 kilometers. The other axis not quite so big. And there's a giant crater there over a kilometer across. It's called Stickney. And I will tell you about Stickney in just a little while. And then here's Phobos. You'll notice that these moons are covered in craters. In the case of Phobos, you can see long striations, which may be from being scraped by meteors hitting it. They may be cracks, and we'll find out about Phobos cracking and having problems with stability in just a little while. So here's a recent picture from just 2 years ago. A very accomplished amateur astronomer taking a picture of Mars, trying to suppress the incredible brilliance of Mars, and then taking pictures of Phobos here, if you look carefully, only over a period of an hour and a half, and you can see how rapidly Phobos is moving around Mars in only an hour and a half. Deimos out here, farther out, moves more slowly. Now, these two moons' orbits lie right in between what would be a synchronous orbit for Mars. Many of you may know, we here on Earth have got a synchronous orbit about 36,000 kilometers above the surface of the Earth, where satellites orbit at exactly the rate the Earth rotates, and that's where we put our communication satellites, so they seem to hang in the sky. They're always in the same spot to facilitate communication, broadcasts, whatever we'd like to use them for. That Martian synchronous orbit is above the Phobos orbit, but below Deimos orbit. And one of the consequences is Phobos's orbit is actually shrinking. Deimos is stable, and we'll come back to that shrinking for Phobos in just a moment. Now, this is an astronomy class, and I like to do calculations, and so I've done some calculations for you about the moons, and I want to share those with you in order to tell you how remarkable it will be to stand on Mars and to see these moons. Now, let's look at the Earth and the Earth's moon. The Earth rotates in 23 hours, 56 minutes, and 4 seconds, not 24 hours. 24 hours is the time from noon to noon, and that's affected by the Earth's rotation, but also by the Earth's orbit around the sun. And so there's our rotation rate, whereas the moon's orbital period about the Earth is 27.32 days, right? The time it takes to go through its phases is 29.53 days, but that too is because during the time it orbits the Earth orbits the sun. So you'll see that the Earth rotates much faster than the moon orbits. The moon orbits in an easterly direction, the same direction that the Earth rotates. And so in one Earth rotation, the moon orbits 13 degrees to the east. That means the moon rises about 52 minutes later each night. And of course, it goes through its phases in that time. If you watch the moon carefully, and if it's passing in front of a star or in front of Venus, as it did recently, then the moon moves through its own diameter in about 1 hour. But it rises in the east, excuse me, and sets in the west. Because the Earth rotates much more quickly than the moon orbits. Mars, it's very different. Mars's rotation period is very similar to the Earth, 24 hours, 37 minutes, 23 seconds. And we call that one sol, sol meaning sun, but instead of 1 day, it's one sol. So I will use that term in a few more of these slides. 1 sol on Mars is a bit longer than our day. Now, pity the poor astronauts someday who go have a base on Mars and try to live there, because if they want to live by the sun and be up during the day, sleep during the night, then they're going to have to change their schedule 37 minutes every Earth day. They're going to have to stay up 37 minutes later every night. That's pretty tough on your physiology. You do that for weeks or months, it's going to cause problems. So the astronauts probably will not remain in their lifestyle synchronized with the sun while they're on Mars. Now, Phobos's orbital period, that little thing is so close to Mars, it orbits in only 7 hours, 39 minutes, and 12 seconds. It's orbiting much faster than Mars rotates. Now, it does orbit to the east, and it orbits in Mars's equatorial plane, just as the moon orbits the Earth to the east. But because it's orbiting so much faster than Mars rotates, it actually catches up with Mars's rotation, and it rises in the west, and it sets in the east. And with Mars rotating, the time from the Phobos rising to the next time it rises is less than 12 hours. It's less than a half of a sol, half of a Martian day. And so Phobos really truly does hurtle across the sky, hence Edgar Rice Burroughs' Hurtling moons of Barsoom. It rises twice per sol. You actually get to see the moon come up twice every single Martian day. Here are some numbers for Phobos. There are its dimensions in 3 different directions. It's got a mean radius of 11 kilometers. It has a mass of 10 to the 16. That's 1 followed by 16 zeros of kilograms. And for any of you who've got any interest in simple algebraic equations, the gravitational attraction, what gives you your weight here on the Earth, is a simple equation that depends on a number, the gravitational constant, and on mass and on radius. And so I calculated the surface gravity for Phobos. It's 1/1719th the gravity of the Earth. And to put that in perspective, I weigh 80 kilograms here on Earth. If I could travel to Phobos, I would weigh 47 grams. Now, as I sit here talking to you, you might even be able to see me in the corner of your picture. I'm moving around a bit. I'm wiggling. You probably are too as you're watching. And I can tell you any little motion you make, if you were sitting on Phobos, would just send you flying. You would take off. Orbital velocity for Phobos. Now, there isn't any simple orbit for Phobos. It's so tiny it would have trouble hanging onto a satellite. But if we imagined a tiny satellite like you, a human, orbiting right above the surface of Phobos, the orbital velocity is 8 meters per second. That is less than the speed an Olympic sprinter runs 100 meters. So an Olympic sprinter, if she or he could get up to speed on Phobos, it's going to be hard because every time you touch the ground and push, you're going to go flying. But if you could get up to speed as you can here on the Earth, a human could launch herself or himself into orbit off this little moon. It's very different from being here on the Earth. On the other hand, with that very, very low gravity, it's potentially a staging point for landings on Mars. We could land on Phobos, and there is a mission coming, I'll finish with that today, and use that with its very low gravity as a staging point to go down and up to the surface of Mars. Now, I've done another calculation. How high could you jump? Well, the height you can jump depends on gravitational potential energy. That depends on your mass. That doesn't change no matter where you are. It depends on the gravitational acceleration, and that then tells you how high you can jump. I have said here, let's assume that a human on Earth can jump 1 meter off the ground. Now, I know a high jumper can clear a 2-meter bar or even more, but that's a gymnastic move. If you imagine a person jumping straight up with feet towards the ground, then a Maasai warrior who does this in a dance, a basketball player, a volleyball player, some athlete who jumps straight up, perhaps gets center of mass a meter off the ground. On Phobos, that person could jump 1.7 kilometers if they're not wearing a lot of spacesuit that weighs a lot. 1.7 kilometers. And the time it would take to get to the top of that before the gravity slowed you down would be 13 minutes. It would take you 13 minutes to get up to the top of your jump and another 13 minutes to come back down. You'd be up for 26 minutes if you did a big jump on the surface of Phobos. Obviously, this is not a place to play volleyball or basketball or any of our earthly games. They would be terribly slowed down by the fact that once you jump to do something, you don't get back down to the ground for a long, long time. Here's the answer to this crater and why it's named Stickney. Angeline Stickney, later Angeline Stickney Hall, American woman who grew up in a rather poor family of very good academic ability, was fortunate enough, even though she came from a poor family, to go to a central New York college in the early 1850s. Now, this college was unique at that time. It's perhaps the predecessor of Cornell College now in New York State. But Angeline Stickney went to Central New York College as a poor student because the college was designed for poor students, and that also it meant it admitted women, which other colleges didn't in the 1850s, and it admitted blacks, freed slaves in the north of America. And not surprisingly, she and her fellow students, although they did their academic work, they were extremely active in political activities. She was a woman's suffragette. She was strongly active in the anti-slavery movement, and politics was discussed at her college as much as academics. They were all activists. She was needing to make money to live on. She shared a room with her sister, who was also at the college, and they had $1 a week to live on, 50 cents for the room that they shared, and 25 cents each for food. So she took a job as a teacher at the college when she was in her senior year, teaching students 2 years younger than her, and she taught them German, and she taught them geometry. And one of the students in her geometry class and his fellows decided that they would trick her and they would make up very hard problems that she couldn't solve to fool her, and they never succeeded. Every problem they ever set for her, she could solve. One of those students was Asaph Hall, 2 years his junior, and they married, having met in college that way. Angeline, as Asaph Hall took a job in Wisconsin, she actually wrote to the director of the Naval Observatory and motivated for him to be hired at the Naval Observatory, and that was how he was accepted and offered a job there. So she pushed for that. And when he was trying to discover the moons of Mars. He got very discouraged because he said, many, many great astronomers have tried this before me and failed. And she encouraged him to keep trying. And she also was doing a lot of the calculations with him. But as a suffragette, as a believer of equal rights for women, she demanded from her husband that since she was doing the calculations, she should be paid the same as a man. Women at that time were paid a pittance compared to men for the same job. And Asaph refused to pay her the same amount, and so she refused to do the calculations for him. That wasn't damaging to their marriage. They still had a strong marriage, but had some strong disagreements too. But it meant that she did not end up with a career as an academic. What she did do was she homeschooled their 4 children, all boys, and all 4 of those boys graduated cum laude from Harvard University later. Had she been born today, she would have had a great career of her own. In honor of her, that huge crater on Mars is called Stickney after her maiden name, Angeline Stickney. There is another crater Hall on Mars named after Asaph Hall. It's much smaller. Now, more facts and calculations. Deimos. Again, Mars rotates in 24 hours and 37 minutes. Deimos orbits in 30 hours and 18 minutes, just a little bit longer. And so although Mars rotates more quickly, so Deimos rises in the east, it takes a long, long time for Deimos to pass across the sky because as Mars rotates, Deimos is orbiting in the same direction. And so from the time from one rising of Deimos to the next one, 5.3 Martian days. Once Deimos comes up, if you're on Mars, it'll hang in the sky before it sets for more than 2.5 days. Very, very different to our own Earth's moon here, which rises 52 minutes later each night. Now, if you were standing on the surface of Mars, on the surface of Phobos and looked up at Mars in the sky, Mars would be gigantic. Now, you may not think about it regularly. When you look up here from the Earth and you look at the moon, it's a 0.5 degree across in the sky. But if you think about it, astronauts on the moon looking back at the Earth are going to see a bigger Earth in the sky. It's about 4 times further across than the moon. And so from the moon, an astronaut looking at the Earth sees the moon subtend, that's the word, about 2 degrees across the sky. From Phobos, if you look at Mars, because it's so close to Mars, Mars would subtend 42 degrees across the sky. If Mars were sitting on your horizon on Phobos, it would stretch halfway to the zenith. So this is a very different experience again, hopefully that someday some astronauts will have. Now here's a real movie shot by the Curiosity rover from the surface of Mars, where it pointed its camera at the sky and watched a transit of Phobos across the face of the sun. Now from Mars, because Mars is 1.5 times further from the sun than the Earth is, the sun's only 2/3 the size in the sky that the sun is here from the Earth. Here on the Earth, the sun is a 0.5 degree in size, the moon's a 0.5 degree in size. That's a coincidence, by the way. In the past, the moon was closer and bigger. In the future, it'll be farther and smaller. But at present, the moon is exactly the right size to cover the sun when it passes in front of the sun and give us our wonderful total solar eclipses. Here on Mars, with Curiosity looking up, it saw Phobos pass across the sun, but even as close as Phobos is, it's so tiny it can't cover the entire sun. But there's a transit of Phobos across the sun, seen for real. Let's look at that once more, by the little Martian rover Curiosity, who pointed its eyes up at the sky to watch this. Now, the origin of Phobos and Deimos is still not fully understood. Joseph Shklovsky, a Russian astronomer, in 1959, studying the orbit of Phobos, discovered that the orbit was decaying. What does decaying meaning? It means that the orbit's losing energy and dropping closer to Mars. And when it does that, the orbital period speeds up. Now that comes from a tidal interaction between Mars and the moon. That happens here on the Earth, or the Earth and the Earth's moon have tidal interaction. Now there are tides in the land as well as in the Earth. And that tidal interaction takes away rotation of the Earth, gives that spin to the moon, and that angular momentum causes the moon to drift away from the Earth. It's drifting away at about 4 centimeters per year. Shklovsky discovered that Phobos is drifting closer to Mars. He then said, not thinking about tides, this was 1959, he said, if this is from atmospheric drag, Mars's atmosphere is so incredibly thin that this isn't going to work unless Phobos is hollow. And so he suggested that it might be a hollow metal spaceship put up by Martians. Excuse me. Well, he may have partly been tongue-in-cheek, but he was extremely interested in the search for extraterrestrial life. And he worked closely with Carl Sagan. They wrote books together. They had arguments one way or the other with each other. They were both very active in the early SETI, search for extraterrestrial intelligence. And so Shklovsky's claim in 1959 that Phobos might be an artificial satellite put up by ancient Martians really caught people's imagination. We know now it's not. You've seen pictures tonight. It looks like an asteroid. And that has been the favorite theory for Phobos, is that it's a captured asteroid from the asteroid belt where Jupiter's gravity would have helped these asteroids drop into orbit about Mars. But there's a problem with that. It's incredibly improbable. Most captured asteroids, Jupiter's got lots of them, orbit in very eccentric orbits, and they can orbit in any old direction, to the east, to the west, over the poles. Whereas Phobos and Deimos both orbit to the east, and they both orbit in the equatorial plane. And that seems very improbable if they were captured. So a current hypothesis is they were formed by collision, a large collision with Mars, which put up a debris disk around it. And out of that debris disk, these mini moons may have formed, and others were shed, and only these two are left. That's currently the best hypothesis for the formation of the Earth's moon, too, that a collision with something the size of Mars hitting the Earth put up a debris disk out of which our moon formed. How can we tell which of these are right? Well, we can go land on Phobos and get some of it and bring it back here to the Earth and see if the chemical composition is the same as asteroids. We've got a return mission bringing asteroid stuff back, or if it's more likely it's made from the stuff from the surface of Mars or from a collider. By the way, Joseph Shklovsky, when he was touring the US in the early 1970s, gave a talk at Berkeley in California. And one of the students in the question time put up his hand and said, Professor, do people in the Soviet Union have as many UFO sightings as we do here in the United States? And Shklovsky laughed and said, no, you Americans are very far ahead of us on that. So how to tell the difference? Well, here it's coming. JAXA, the Japan Aerospace Exploration Administration, is planning and has been planning for over a decade and is building the Martian Moon's Exploration Mission, MMX. It's currently scheduled, if it goes on schedule, to be launched in September of 2024 from the Earth. It will get to Mars and then go into a very peculiar orbit about Phobos. Now, Phobos doesn't have enough gravity to hold something permanently in orbit, but there are some remarkable semi-stable orbits that it can be put into where it will stay with the moon for many months. And it will then land on the surface of Phobos, and it has a pneumatic device to punch into the surface and suck up about 10 grams of the surface dust and rock to then be kept on board and be brought back to the Earth. It will go visit Deimos too, but not land, just orbit Deimos, take pictures and study it. And then it'll return launch from Mars in August of 2028. Now, it takes about 7 months to get from the Earth to Mars. And you can only launch at a certain time when the Earth and the Mars are in the right position. It's called the launch window. And when you get to Mars, you can't just come home anytime you want. You have to wait till Mars and the Earth are in their right positions in the orbit so that when you come back and get to the Earth's orbit, the Earth is actually there to receive you. And so there's the time. This mission is intended to return to the Earth in July of 2029. If this goes on schedule, we should be seeing material back from Phobos and getting some answers to these questions, along with fantastic views of these little moons coming up in this decade. So thanks for your attention tonight, folks. We'll move to questions now. Right, Andrei, there you are.
Thank you. Thank you very much, Don, for very fascinating talk with lots of information. I also was Intrigued to find out that I have something in common with Carl Sagan. His ancestry comes from my country as well. Very, very, very fascinating talk. And we have questions that to come. And I read question from Jack Martin from United Kingdom, who first of all wishes Happy New Year. Then he tells that he thought that mission to Mars was one-way ticket. And then he basically was asking when we expect a human mission.
Right. Jack, first, good evening to you. I certainly remember meeting you at Astrofest many times. I hope your spectroscopy is going well. And, you know, there's been talk of a one-way mission to Mars. It's hard to get humans back home again. Most nations are not willing to send astronauts out on a suicide mission. The public just isn't comfortable with that idea. You could get sane people to do that. It would not be insane if you were an adventurer and wanted to be the first person ever to go to Mars, to go knowing that you wouldn't get to come home and you weren't going to survive it. But I don't think that that's politically viable. We're going to want to send people to Mars and bring them back again. Technologically, we're mostly capable of that already, but a major barrier is protecting the astronauts from radiation in space. Major part of that radiation comes from the solar wind, just high-speed protons from the sun, and particularly solar flares. To give you an example, during the Apollo space missions, when astronauts went to the moon, once those astronauts were beyond the Earth's magnetic field, the Van Allen radiation belts, they had no protection from flares from the sun. Between Apollo 16 and Apollo 17, there was an X-class flare that blasted the Earth and the moon. If the astronauts had been out at that time, they would have been killed instantly with no warning. They took a chance. They were braver than the public was told. The problem with going to Mars is you've got 7 months to get there. And then you land on the surface and you've got to stay a while before you can come home again. You can see the MMX mission is going to be 5 years. How do we protect those astronauts against flares from the sun? And also just from the continuous cosmic rays, which eventually will cause cancer and problems with their physiology. There are ways to do that. Water is a very good protector. You can build a wall out of water, but it's incredibly heavy, and now you haven't got the power to launch your satellite. So there's the big unsolved problem in sending people to Mars. We've got the technology. If we're willing to spend the money, we can do it, but we don't yet know for sure how to protect the astronauts from space radiation.
Thank you, Don. A question from Rob Wheeler. Many thanks, Don. What techniques would give us more information about the striations on Phobos?
Well, that's a good question, Rob. Thank you very much for that question. It goes beyond what techniques, but I forgot to tell you something, and you've now reminded me. Because Phobos its orbit is shrinking, and it's getting closer and closer to Mars. It used to be thought in 100 million years. The latest calculations say 39 million years. It will get so close to Mars that the tides from Mars will shatter the moon and break it into small pieces, and those eventually will re-enter the Martian atmosphere. And so Phobos is going to die on a time scale of current best guess 39 million years. It's not permanent. So the striations, one thought about the striations is they might be cracks already from the tides beginning to stress that moon. I think from the look of my own personal view, not that it's expert, but just looking at them where you can see that string of craters. There's strings of craters on the moon too, where asteroids come in at a low angle and then bounced across the surface. And that string of craters coming out of crater Stickney, perhaps whatever hit Stickney, the debris that flew out just striated the surface. How can we know better? I would think that the close-up pictures and the studies coming from the MXS mission are going to give the people who study the surface of that a much better data at incredible detail in order to try to answer that. Are those striations from things bouncing along the surface, or are they cracks beginning to show from the tides tearing Phobos apart? Phobos is doomed.
It's quite sad future for Phobos, but let's continue with questions. There's a question from John Levenhall. Is there any chance Phobos and Deimos might collide? Can be that calculated, or it is a three-body problem?
Right, thank you. That's also a very interesting question. Yes, it can be calculated. And what has been done is calculations have been made about what the orbits of Phobos and Deimos would have been like in the past, trying to figure out, are they from a collision with Mars and formed out of a debris disk? Are they captured? And backwards calculations indicate that the two of them may have passed close to each other in the past. And if the model that a collision with Mars put up a debris disk is right, then probably there were many, many moons and they were interacting with each other. And many of them in the interaction got flung away or flung into Mars, and Phobos and Deimos are the survivors. And now, because one is below the synchronous orbit and one is above, Phobos's orbit is shrinking, it's moving away from Deimos, and Deimos's orbit is essentially stable. So they're not thought that they will collide in the future as Phobos goes down. Now, I want to go back to what you just said, Andrei. Probably Saturn long in the past had a moon that was shattered, and that produced its spectacularly beautiful rings. And so instead of thinking it is sad, when Phobos shatters, it'll form a ring around Mars, and at least for a while, it's going to be beautiful.
Yes, thank you. Question from Jim K. Are there any estimates of when Phobos might impact Mars or be tidally disrupted? So it's a question which you basically said around 40 million years, right?
The estimates range between 40 million and 100 million, Jim. And so in terms, for you and me, it means very soon, if you're an astronomer. Not in our lives, but astronomically, in terms of the life of the solar system, very soon.
Now there is a now question from AC, who is our permanent member of audience. Could Phobos fracture into multiple moons from its tidal stresses?
Oh, AC, yes, and hello to you in San Diego. Yes, it could. Yes, it will. Well, let me just say, look, I'm not absolutely certain. Like it's possible that the moon will just crash into Mars intact, and then it's going to be a terrible explosion on Mars. But best guesses are that it will shatter before that happens. But still, all that stuff coming down is going to bring in terrible energy. And if we had a 20-kilometer long rock crash into the Earth, this is an extinction event in terms of the energy released. And so this is going to produce craters, explosions, Mars quakes. If humans are living on, well, humans, 39 million years, are there going to be humans? That's another question. But if something were living on Mars when this thing comes down, the things living on the surface are in trouble.
All right, and AC continues with one more question. How possible it could be for Phobos orbit to be artificially boosted to prolong or permanently allow its survival?
That's an interesting question, AC. As you know from the DART mission, which I talked about a couple of months ago, we've already developed the technology to divert asteroids and to change their orbits. If for some reason we thought that it was environmentally or just desirable in terms of aesthetics to keep Phobos up, could we land on its surface with a rocket facing down and fire the rocket and lift it to a higher orbit? That's what the space shuttle did every time it went up to the Hubble Space Telescope. Every time it brought it on board, it also lifted the Hubble Space Telescope to a higher orbit, because ultimately the Hubble Space Telescope is coming down too. That's from friction with the air. So could we do it? In principle, yes, but you know, that thing weighs 10 to the 16 kilograms. It's going to take a lot of energy. And I can't imagine wanting to spend the money on that. If there were Martians and they wanted to keep their moon, would they do it? Well, if you'd like to write a science fiction story, there's a topic for you.
Thank you. Thank you. There is a question from James Christopher Hunt, who is asking about historical numbers. He basically tells, I believe you may have conflated Copernicus with Kepler earlier. Copernicus died before the discovery of the moons of Jupiter by Galileo in 1610.
My goodness, you are absolutely right. I certainly did. I did mean Johannes Kepler. Thank you. Oh, geez. And you know, this thing's going to stay there on YouTube. So thank you for actually putting that correction in. I made that slide today, and I'm currently reading a biography of Copernicus. So you're right. It was Johannes Kepler who was the one who made that estimate that because the Earth has one moon and Jupiter has four, Mars should have two in a geometric progression. Perhaps, Andrei, I should correct that slide and you can replace the YouTube video with the correct slide later. Can you do that?
We'll need to ask Sergey, who is working behind the scenes. How does it work?
Thank you very much for that correction. You're absolutely right.
Now there is a question from Jim K again. Do we know whether the moons are tidally locked?
Oh, yes. Phobos and Deimos are both tidally locked to Mars. And so they keep one face towards Mars as the Earth's moon keeps towards the Earth. Yes, they are. They're both tidally locked.
Thank you. I actually wanted to ask about this mission. You said that we have to bring material to Earth. Is there any chance that spectroscopic machines can be placed on this mission and all analysis done there rather than coming back to Earth?
Oh, Andrei, we can do a little bit of spectroscopy. You mean looking at the individual particles? Bringing it back to Earth is much better because we've got much bigger, more powerful machines where we can do much more detailed study. And so it's better to bring it back. You haven't got the energy and the money to launch giant machines to do mass spectroscopy on something like Phobos. So bring a little bit back rather than send a huge thing there.
Right. Okay. Thank you. Thank you. Just looking for questions coming.
You folks are free to ask questions on any other topic you like during these Astro-Chats too.
Yes, so we just waiting for new questions to arrive. Okay, now Jack Martin, I know, just Iris first. What? It's a bit difficult. What looks moon tidally locked? Okay, there's one more question from AC. Is it known if Russian Phobos 1 moon probe crashed into one of the moons?
Oh, no, I don't know the answer to that, AC. That was a failed mission. And I don't actually remember if there's any later statement about whether it crashed into the moon or whether it missed. You know, about half of all missions to Mars and to Mars's moons over time have failed. Been a lot of failures. And I personally don't remember what happened to that one. I'd have to look that up. You might like to think, if you like to think in terms of science fiction, imagine that you and some enemy are standing on the surface of Phobos and you're hiding from each other, but you're in a battle and you've now got to go get your enemy. You can call this paintball if you like. But this is 20 kilometers long. This thing's got a lot of surface area. And so now you would like to search for your enemy and avoid being seen yourself. And one way you could do that is you could just jump. Now for the next 26 minutes, you're up with practically a view of the surface of the entire moon. You might find your enemy, but you're flying duck if you do that. And if you'd like to crawl along the surface, that's not so easy. Every motion you make, given that, remember, I would only weigh 47 grams, every little motion is going to send you quite high up off the ground. And so if you were having a game of chase on the surface of Phobos, a game of paintball, this is a really difficult challenge. I don't know when there's going to be enough money for that to be a sport, but it's going to be very different from here on the Earth.
Thank you. There is actually a question about science fiction from Minerva Bird. Don, who is your favorite science fiction writer?
Let me think about that. I don't read science fiction anymore, not because I'm against it, but I just kind of lost interest. But when I was young, uh, coming up to my teens and throughout my teens and into my early 20s, I read ravenously. And so my answer to your question is not going to be a recent writer. And so I like the old hard science fiction authors who didn't have much characterization, Arthur C. Clarke, Isaac Asimov. I like their stories because the stories were based in science. They weren't too great on character development. That's part of the reason I don't read science fiction anymore. So those were two of my favorites, but there were lots of others that I liked.
Thank you.
Actually, speaking of authors, just for a moment, let me actually say that this being 2023, Edgar Rice Burroughs, were he alive today, we would not invite him to come speak on our university campus, and we would shun him completely. He was a blatant racist and eugenicist. He thought that criminals inherited their criminality and that the right way of treating criminals was to execute them and all of their families so that no genes could be propagated into the future. And we simply wouldn't tolerate the man as he was now. More than a century ago, those sorts of attitudes were allowed, at least within public in America where he was living. And so he had a career where he became famous and he made a lot of money, but he also became quite a bastard when he got older, and he was a serial divorcer of his wives when he became rich. So although I put in Edgar Rice Burroughs there because I liked his science fiction, because of who he is as a person, I would not label him as one of my favorite science fiction authors. Whereas I was an admirer of Arthur Clarke and Isaac Asimov as people.
Thank you, Don. Now this question from listener Timur. I wonder, is it possible in future to send robots with artificial intelligence to Mars instead of real astronauts?
Oh, Timur, well, good evening to you too. Nice that you've come and joined us from the room next door, possibly. The answer is certainly yes, and many people advocate that. Why should we send humans, delicate, easy to kill, sickly humans, off on a mission like that when we can send robots? Whether they're intelligent or not, they can talk to us. And many people think that it's wiser to send robots. But since you've brought up intelligence, look what's happening with this ChatGPT, the AI robot, which is, I read an article today in the newspaper that it had put in an application for a job with a communications company. And the task that was given to the applicants was to write 300 words on what makes good writing. And this computer was shortlisted for the job. It was in the top 20% in terms of the quality of its writing about what makes good writing. Artificial intelligence is changing so rapidly that sending artificially intelligent robots to the planets, they're going to survive better than humans. It may be the only choice, but it's just that we humans want adventure too. We want the idea of a human standing there, and vicariously we can enjoy that they're actually standing on that moon, looking at Mars, or standing on Mars, looking down into the canyon and experiencing it as a person. And that's a human choice. It's not the wisest financial choice in terms of how much the mission will cost. And it's almost certainly not the wisest choice in terms of getting the science done.
Thank you, Don. This question from Jane Elizabeth Madison. I think you said something about using Phobos to launch probes to Mars. Why would that be available?
Oh, Jane, all I said was that it might be a staging point where you could do that. If you're on the surface of Phobos, it's extremely easy to get off the surface and back onto the surface, whereas Mars has got a much stronger gravitational field. And so you might take equipment to Phobos and then easily get it off of Phobos and take it to the ground. I'm just speculating when I said that might be something to do. Missions to Mars, if we could do it, might be easier to launch from the moon than from Earth. If we could get a permanent base on the Earth's moon and build things on the moon, because of its lower gravity, it's much cheaper to put things in orbit. You can lift a lot more mass into orbit. And so the idea of using Phobos as a staging point is just to take advantage of its very low gravity as a nice stable place to be in orbit about Mars. But it may be that just being in a satellite orbit is perfectly all right for a mission. Some people have just speculated it might be a staging point, and I threw that in.
Thank you. And a question from Iris first, which is in fact related to one of our previous charts. Why are moons tidally locked? What causes this?
Iris, there are tides between any two bodies orbiting each other. There's tides between the Earth and the Moon. There are tides between the Sun and the Earth. There are tides between two stars orbiting each other. And those tides are actually a stretching force where the gravity is different from one side to the other. And so if a moon were perfectly spherical and perfectly uniform in its density, then the tides wouldn't have any particular effect on its rotation or its orbit. But those moons are oblong. You could see they're kind of potato-shaped. And what that means is that the differential gravity can tug on one side more than another. And likewise, the moon tugs back on Mars. And that interaction, Earth's moon and Earth, or Mars and its moon, means there's an exchange of angular momentum, exchange of spin. And in the case of the Earth's moon, it would have in the past been spinning faster, but the tides tugging on the Earth are slowing the Earth's rotation down. The Earth has already slowed down the moon's rotation, and that spin, which can't be destroyed, is going into the orbit, and the two bodies separate. In the case of Phobos, because it's so close to the surface of Mars and inside the synchronous orbit, and given its shape, those tides are actually causing its orbit to shrink. So you asked about tidal locking. The tidal locking comes because of the differential gravitational force across the body, and the body not being uniform in its mass distribution allows the thing tugging on it to slow its spin down, and that spin then goes into the orbit or to the spin of the other body. Any two bodies orbiting each other have tidal interactions. The stars I work on, some of which orbit each other in only 1 or 2 days, are totally stretched out of shape. They're teardrop shaped from the huge tides they raise on each other.
Thank you, Don. Yeah, we've got quite a few questions at the end, but time is approaching. There's a question kind of on terraforming Mars, kind of, from AC. In your opinion, how feasible do you think it is that Mars could be terraformed to at least to have a dense atmosphere, so not to require spacesuit on its surface?
AC, I don't have an expert opinion on that. I certainly have read about terraforming, ideas for it, perhaps planting bacteria on Mars, which would breathe in carbon dioxide, breathe out oxygen, or bacteria that would help raise the carbon dioxide level in the atmosphere, producing a greenhouse effect that would heat the planet and then sublimate more carbon dioxide to produce a thick atmosphere. Ultimately, once you got a thick atmosphere, you do have to pump oxygen into it too, presumably by planting life on Mars. I don't know how feasible that is. I do worry about it, though, in that we don't want to do that until we make sure that there's nothing native living on Mars. Now, we know there are no Martians. There are no Martians going to attack the Earth in the War of the Worlds, but we do not yet know that Mars doesn't have indigenous native bacterial life living underneath the surface. And if there is naturally life on Mars, then we do not want to contaminate it with life from the Earth until we've studied the life on Mars, and we may never want to contaminate it. That's going to totally mess up the ecosystem there if we did that. There's some big questions. But your question was, how feasible do I think it is to do that? I don't know how feasible it is, but I think that engineers and scientists are very clever, and because there's nothing in physics that says you can't do it, ultimately a solution can be found where we could cause Mars to build up an atmosphere. But then you have the problem, no magnetic field. What's going to protect you? Or weak magnetic field. What's going to protect you from the radiation from the sun? You've got another problem there too, not just thick atmosphere.
Thank you. Thank you very much, Don. And thank you everyone who are with us tonight. We do have more questions, but our time is up, and we keep it to 1 hour. So again, thank you everyone who came, who asked questions, participated in this lively discussion, in this Astro-Chat. Thank you, Don. And we will look into the future chats about various interesting astronomical things. Thank you.
Okay, thank you everybody for coming. Good night or good day.
Good night and good day.
Yes, bye.